This is a key to topic 19, part B, worksheet 1. And in number 1 and also in number 2, so remember there are 2 pages to this, you're given 2 functions, f and g, in each, and you're asked to perform operations on those functions. So in number 1, let's look at number 1, we have, number 1, we have f of x, we'll write down the function, f of x equals 4x minus 3, so you have these two linear functions. And g of x is the linear function x plus 5. And in number 1, you're given this. And you have to know the definition of what you see. So basically, this is a plus symbol. So basically, this says that you're going to add 2 functions at x. And so by definition, this means g of x plus f of x. And so you're adding 2 functions, these 2 functions together. So so really this is an easy one because you're indicating what g of x is. So g of x is this function here, x plus 5. Right? So g of x is this, plus, and then f of x is this, 4x minus 3. And notice that since I'm adding these, it's not necessary to put those in parentheses. And so the answer is just x plus 4x is 5x, and then 5 and a negative 3 is a negative 2. So that's the function g plus f at x. So the answer, you're going to say g plus f at x is going to equal this function here, 5x minus 2. So when you add those functions, you get this function. All right, so that's the algebra functions, or the combination of functions. So that's number 1. So number 1, the answer is 5x minus, I'm sorry, 5x plus 2, excuse me. 5 and negative 3 is 2, so 5x plus 2. All right, now make sure, notice it does say show the work, so you have to show the work. So the work is going to be on next page. So work is on next page. All right, now number 2, in letter B rather, so this is number 1, and then letter A. And letter B, you're given that you want to do this operation on those functions. So now you're subtracting. Now remember, subtraction is not commutative, so the order does matter. So since g is listed first, you must put it first. So by definition, this is g of x minus f of x. And so g of x, remember, is this function here. So that's this linear function, x plus 5. And remember, you are subtracting this function here. So you're subtracting all of these terms. So many of you did this and you messed up because according to this, you're only subtracting 4x. Remember, you have to subtract all of this function. So multiple times we have indicated you need to put that in parentheses. And so now we're going to get rid of the parentheses either by distributing a -1 or by taking the opposite of each term. And so I get x plus 5. The opposite of 4x is a negative 4x, and the opposite of a negative 3 is a positive 3. Combining like terms, x and negative 4x is a negative 3x. 5 and 3 is 8. So therefore, when I subtract those functions from each other, when I subtract f of x from g of x, I get this new function, negative 3x plus 8. All right, so that's letter B. So the answer to letter B is negative 3x plus 8. Okay, let's look at C. So in C, this time, again, we're dealing with these 2 functions in number 1. So in letter C, you're given this. So you're given this notation, and you have to remember that this notation, see that closed dot right here, that means multiplication. So you're going to be multiplying those functions together. So we have f of x times g of x. So that's what that definition means. So that's what this means by definition. That's f of x times g of x. All right, now remember, don't confuse that to mean f plus g times x. That's not multiplication right here. That notation means f times g at x, okay, not times x. Okay, so now what you're going to notice is that, hey, since I'm multiplying these 2 functions together, and f of x is this linear function, which is a binomial, I'm going to have to put that in parentheses because all of these terms will have to be multiplied by whatever g of x is. And g of x is this linear function, which is also a binomial, x plus 5. So that must be put in parentheses. And now notice you have to simplify this. So you are expected to use the FOIL method to get rid of these parentheses. So 4 times x is 4x squared. The outer, 4x times 5 is 20x. The inner, negative 3 times x is a negative 3x. And the last, negative 3 times 5 is a negative 15. Combining like terms, I get 4x squared. 20x and a negative 3x is 17x. And then minus 15. All right, and so therefore, when you multiply those two functions together, you get a new function. So when you multiply these two linear functions, your new function f times g at x is going to equal 4x squared plus 17x minus 15. All right, so that was letter C. Now in letter D, so in letter D you have this. All right, in letter D you have this notation. And notice that you're dividing, so that's a quotient right here. So remember, division, just like with subtraction, is not commutative, so the order does matter. So according to this, you must put g of x in the numerator. So that's going to be g of x divided by f of x. And g of x is this linear function, x plus 5, and then f of x is 4x minus 3. Now, keep in mind, though, that at some point, whenever you're dealing with rational expressions, you have to reduce. And so to reduce, you may need to factor. Now, both of those are not factorable. And so x plus 5, there's no x plus 5 in the denominator as a factor, so there's your answer. You cannot do anything further with that. So really, there was no work that was necessary for this problem. And the same thing with E. If you look at E, this time you have f divided by g evaluated at x. So by definition, that's f of x divided by g of x. And f of x, remember, is this linear function for x minus 3. And g of x is this linear function, x plus 5. And so notice that, again, I cannot reduce this any further because I can't factor this any further, either one of those. And those factors are not the same. And so I want you to notice, though, that g divided by f, its reciprocal is f divided by g. So if I found letter D, g divided by f, then f divided by g is just reciprocal of this. All right, so that was number 1. Now, number 2, we have this a new set of functions in number 2. So this was the functions for number 1. So the functions for number 2 are these. So number 2, you have, we're going to write it on here. So number 2, you have that f of x is this linear function, 3x plus 1. And g of x, though, is quadratic. It's this function, 3x squared minus 11x plus 4. Okay? All right. Now, in number, in letter A of number 2, you have this. So this is 2a. So in 2a, you have this notation. And again, you need to know that this means f of x plus g of x. And so basically you're going to be adding these two functions together. So f of x is this linear function, 3x plus 1, 3x. And then g of x is this quadratic function. So it's 3x squared minus 11x plus 4. No parentheses are necessary because I'm just adding those. And now combining like terms, 3x squared, 3x and a negative 11x is a negative 9x. 1 and 4 is 5. So I get this, when I add these two functions, I get 3x squared minus 9x plus 5. Okay? So that was number I'm sorry, I didn't mean 9. That's what, 8x, right? So 8x. So 3x and a negative 11x is 8x. All right, so that's number 1. Letter A. Letter B, we have this. We have g of x, g minus f at x. So that's what you're given. So by definition, you have to know that this means g of x minus f of x. And so now you're subtracting, so you have to be careful. Maybe you got to put this function in parentheses. So remember, whenever you subtract, put this in parentheses. So we get g of x, which is this quadratic function That goes here. So that's going to be 3x squared minus 11x plus 4. And you're subtracting in parentheses f of x. So you're subtracting all these terms. So that's 3x plus 1. All right, now get rid of the parentheses, either by distributing a negative 1 or by taking the opposite of each term. So I get 3x squared minus 11x plus 4 minus 3x, because negative 1 times 3x is negative 3x, or the opposite of a positive 3x is a negative 3x. Negative 1 times a positive 1 is a negative 1, or you can say the opposite of a positive 1 is a negative 1. Combining like terms, I get 3x squared. A negative 11x and a negative 3x is a negative 14x. 4 and a negative 1 is a positive 3. So therefore, g minus f at x. So when you subtract those two functions here, you're going to get the new function, 3x squared minus 14x plus 3. All right, so that's letter B. Let's look at letter C. So in letter C, this time, and I have room here, so I'm going to do it on this one. So this time, instead of saying g minus f evaluated at x, this says f minus g at x. All right, so by definition, this is going to be f of x minus g of x. Okay, and so f of x, remember, is this linear function 3x plus 1. But remember, you're subtracting, so you got to put that in parentheses. So g of x is this quadratic function, so 3x squared minus 11x plus 4. And now get rid of the parentheses, distribute the negative 1, or take the opposite of each term. I get 3x plus 1. The opposite of 3x squared is a negative 3x squared. The opposite of a negative 11x is a positive 11x. And the opposite of a positive 4 is a negative 4. Combining like terms, and let's put in descending order, I get negative 3x squared. 3x and 11x is 14x. 1 and a negative 4 is a negative 3. So you get negative 3x squared plus 14x minus 3. So that is f minus g at x is this. So that's your new function. All right, now I want you to notice something. You see right here where you had g minus f? Well, the opposite of g minus f is f minus g, and that's what this is. So these two right here are opposite of each other. So if you found this one, then you know that this one's going to be the opposite of this. So the opposite of 3x squared is negative 3x squared. The opposite of a negative 14x is a positive 14x, and the opposite of a positive 3 is a negative 3. But you still have to do the work. But I just want you to notice that hey, since those are opposites, whatever answer I get here better be the opposite of this one. Okay? All right, so that was C. Now let's look at D. So in D, you have this notation. All right, so keep in mind, again, the closed dot, that's multiplication. So by definition, that's f of x times g of x. Now again, you're going to need that. You need to put that in parentheses. So f of x is this binomial. So 3x plus 1 times g of x, which is this quadratic. So you have this polynomial, 3x squared minus 11x plus 4. Now, notice that in a previous problem when you multiplied, you had two binomials, but this is not two binomials. That's a binomial times a trinomial. So you cannot use a FOIL method here. You have to resort to the distributive property. So basically, if you recall, what you're going to do there is you're going to take each of these terms here, and you're going to multiply it by this polynomial. So you're going to say 3x times this quadratic, 3x squared minus 11x plus 4, plus 1 times this quadratic, 3x squared minus 11x plus 4. So basically, you took each of these and you multiplied it by this polynomial. So this times this plus this times this. Okay. Now get rid of the parentheses here, the distributive property. Same thing here. I get 3x times 3x squared is 9x cubed. 3x times a negative 11x is a negative 33x squared. 3x times 4 is 12x. Now 1 times, see this one, so 1 times this polynomial is that polynomial. So that'll be just 3x squared minus 11x plus 4. And now combining like terms, I have 9x cubed as the only cubed term, so I'm just going to rewrite it. I have two x squared terms, a negative 33 and a positive 3 is a negative 30. So I have negative 30x squared. I have two linear terms, two first degree terms, a 12x and a negative 11x is just x, and then your constant 4. All right, and so there's your product. So f times g at x, so when I multiply these two functions together, I get this cubic function now. So I get 9x cubed minus 30x squared plus x plus 4. All right, and then in letter E, I have f divided by g at x, and by definition, see this quotient, you have division, so you must put the numerator first, f of x divided by g of x, and so f of x is 3x plus 1, g of x is this quadratic. All right, now let me mention something here. In the problem, in letter D, you're asked to factor reduce. The problem with this is when I wrote down the function here, when I wrote this down, I meant this right here to be a negative 4. Subtract 4. That's what I meant it to be, and I didn't. So therefore, when I wrote this right here, this cannot be factored. So that's all you can do. All right, so it cannot be factored. But if this were a minus 4, then you one of your factors here would be 3x plus 1, and you'd be able to factor those. So that's what I meant it to be. I meant this to be minus 4 right here. And then over here, you would then be able to factor and reduce. All right, so that was a mistake on my part, but this no longer applies. You cannot factor and reduce. That's all you can do. Okay. All right, so that was the key to topic 19, part B.